Hello, welcome back. In the first part of this problem, we saw for the reactions, and here we have them at the fixed support. We have the moment 125 kip foot. We have the force AY as 20 kips, and then the internal hinge, the internal shear at point B due to the hinge support is 12 kips, and at support C, CY is 12 kips. So we have all the value we need to be able to draw our moment and shear diagram. So let's start. So to start, we realize that to draw a moment is a shear diagram, realize that the area under the load diagram makes your shear diagram. I say it again. The area under the load diagram makes your shear diagram. So we have force AY as 20. So you start and it's positive. So this point 0. And so from this point up is positive. From this point down is negative. So we go 20 kips up. We are really not scaling this, so we just eyeball it. So these are 20 kips, and it's so from that point you move along the beam. There's no other force from here until you get to the 8 kip force, which act downward. So you just go horizontally. There's nothing here. So that force 8 kips act downward. Okay, so 8 minus 12, 8 minus 20, that's 12. So that means that this point is, this point 20, that means that this point is 12. Okay, and from that point on, there's no other force until you get here. Okay, when you get here, from this point, like I mentioned before, the internal shear here does not show up on your shear diagram. It's internal. It's going to show up here a little bit on the moment diagram, but on the shear diagram, not really. So at this point here, you have this, from this point, you have this uniformly distributed load, and it's 24 kips. When you multiply this 3 by this 8, it's 24 kips, and so your curve is going to act linearly. It's going to be linear. Here is constant. There's a constant graph, but here, because of the distributed load, uniformly distributed load is going to act linear. So 24, and we have 8 foot length. So that means this linear distribution is going to make a transition at the center of this 8 foot. So let's start. Zoom this my 4 foot point. Okay, so don't forget that this is 12 kips. All right, this is 20 kips here. Same thing here. So we already know what CY is 12, and act upward is positive. So when you take that 24 and minus it from the 12, so you're going to have minus 12, and that's what we have here. We have minus 12 kips. And so when you that minus 12, you add this 12 to it, you come back to 0. And so that closes your shear diagram. You must come back to 0. If you do not come back to 0, then there's a problem with the solution of your reaction. So this is a negative here, and this is a positive here. All right, so that's your shear diagram. This is your point 0, and the maximum shear here happens to be a positive 20 kips. All right, so now let's move to the moment diagram. Now the area of your shear diagram, the area under the shear diagram, the area under the curve of your shear diagram makes your moment at that point. So let's start. But before we go on, don't forget that we have this a fixed support here, and we have a 125 keep foot. So that means you're starting with a 125 keep foot of moment. So that's going to be a straight up moment, like a jump. It's like a jump from point 0 up. So what's one? So that's point 125 keep foot. All right. So, and then you now look at the area under this curve here. So we have 20. This length here is 3. So 20 multiplied by 3, that will be 60. 60 minus 125. You minus 125. You minus 60 from 125. So you're going to have 65. So your 65 is going to be somewhere here. Don't forget, we are not doing this to scale, but use your judgment to scale it by eyeball. All right, so we have this is point here. It says 65 keep foot. Now we have another jump, another moment jump, a concentrated moment of -5 keeps. So that -5 is going to create a sudden jump. And because it's negative, it's going to bring your graph downward. Okay? So this 65 minus 5, that will give you 60. So that means this point here is 60 keep feet. All right. So you're here. So from that point, you look at this section here, that's 12, and the dimension is 5 feet. So 5 multiplied by 12, that is 60. Interesting enough, that 60 will take you to this point, which is correspond to the point of your hinge on your load diagram. And remember we said at that point, there is no moment. So this brings us back to point 0. Okay, that's very interesting. So that means we are correct in what we do, because in what we did before, because we arrive at 0 and the graph agree with that theory that at hinge the moment is 0. So you can actually start your moment diagram from this section if you want to, since you know intuitively that this hinge here is the moment at this hinge here is 0. Anyway, we're here. So we've got here. So at this so now we need to find a moment for this section here. So this is a triangle. So don't forget we are here already. We completed this one here. So this triangle here is 12 multiplied by half of this, 8 is 4. So 12 multiplied by 4. Don't forget it's a triangle, so you divide that by 2. So 12 multiplied by 4, that's 48, divided by 2, that's 24. And because the graph is linear, it's going to create a parabolic curve on your moment diagram. It's going to create a parabolic curve on your moment diagram. So the parabolic start from that point, here 0, and we'll come to a maximum here. And then the other section is also 24, because 4 multiplied by 12, that's 48, divided by 2, that's 24. And since we are on 24 here, and that -24 brings you back to 0 point. Okay. So this is 24 keep feet. All right. So this is your moment diagram. This is your moment diagram. This is your shear diagram for this solution. I hope it's straightforward, and I appreciate comments, and you can watch the video again to see how the problem, was how we solved the entire problem from the first section to the second section. Thank you. Stay tuned.